This is your presenter Asloob Mudassar, and I am presenting slide number 44 of the course on laser physics. Question is, the transition rate between two levels for the case of a single atom, that is W21 is equal to W12, was established earlier using a quantum electrodynamics approach. Derive an expression for the transition rate for the case of a black body radiation using Einstein's thermodynamic treatment. Answer. The formula W is equal to 2 pi square over 3 n square epsilon naught into h square multiplied by absolute square of mu multiplied by rho multiplied by delta of nu minus nu naught was derived for the monochromatic radiation in equation number question 36.14 for the case of a single atom. Assume that a material is placed in a black body cavity with walls at temperature T and a thermodynamic equilibrium has reached. An electromagnetic wave energy density with a spectral distribution rho nu naught is given by rho nu naught is equal to 8 pi nu naught square divided by Cn raised to power 3, and this term is multiplied by h nu naught over e to the power h nu naught over kt minus 1 as shown in equation number 44.1. Three processes occur within the cavity: stimulated absorption, stimulated emission, and spontaneous emission. Einstein defined the transition probabilities as W12, that is for the absorption case, is equal to B12 multiplied by rho of nu naught as given in equation number 44.2. And for the stimulated emission, we have W21 is equal to B21 multiplied by rho of nu naught as shown in equation number 44.3, where B12 and B21 are the constants known as Einstein B coefficients. At thermal equilibrium, the number of transitions per second from level 1 to level 2 must be equal to the number of transitions from level 2 to level 1. Considering N1e and N2e as the equilibrium populations of level 1 and level 2 respectively, then these processes, that is the three processes, can be linked through the equation number 44.4. That is B12 multiplied by rho of nu naught multiplied by N1e is equal to B21 multiplied by rho nu naught multiplied by N2e plus A and multiplied by N2e. The term on the left hand side is the absorption term, which gives the rate of absorption from level 1 to level 2, whereas on the right hand side we have the emission terms. The term containing B21 is actually the stimulated emission term, and the term containing A is actually the spontaneous emission term. Where capital A gives the rate of spontaneous emission, from Boltzmann's statistic for non-degenerate levels, we obtain the relationship that is N2e divided by N1e is equal to e to the power minus h nu naught over kt. Solving equation 44.4 for rho nu naught, we obtain rho nu naught is equal to a over b12 into e to the power h nu naught over kt minus b21 as shown in equation number 44.5. So in obtaining equation number 44.5, we have eliminated the variables N2e and N1e from equation number 44.4 using the term shown over here, that is N2e over N1e is equal to e to the power minus h nu naught over kt. So using these two terms, we have using these two equations, we have eliminated and the two variables N1e and N2e, and we obtained the equation shown in over here, that is in equation number 44.5. Comparing equation number 44.5 with equation number 44.1, So let me show equation number 44.1. This is the equation. So both expressions are the rho nu naught expressions. So comparing 44.1 with 44.5, we obtain the following relationships, that is B12 is equal to B21. So let's call them as capital B, and A over B is equal to 8 pi h nu naught cube divided by c to the power 3. This is equation number 44.6. So equation number 44.2 and 44.3 thus reduce to, that is this equation 44.2 and this equation, that is 4.3. So these two equations will reduce to B12 is equal to B times rho nu naught is equal to B is equal to, sorry, W12 is equal to B into rho nu naught is equal to W21. So let's call these two W's, that is W12 and W21, since they are equal, let's call them as only W, capital W. So that is the transition probability for the stimulated absorption, which is W12, and the stimulated emission process, that is W21, are equal. The elemental transition probability dW for a black body with spectral energy density lying in the frequency range between nu and nu plus delta nu is given by. So we have obtained this relationship, that is the equation number 44.8 from equation number from this relationship that we have shown over here, that is W in the start. So this relation can be written for the incremental dW, and then we can write it as shown in equation number 44.8. So the elemental transition probability, that is dW for a black body with a spectral energy density lying in the frequency range between nu and nu plus delta nu, is given by. So dW is equal to 2 pi square over 3 n square epsilon naught h square multiplied by the absolute square of mu multiplied by rho nu d nu and multiplied by delta of nu minus nu naught. And if we integrate this equation on both sides, on the left hand side we have capital W, that is equal to 2 pi square over 3 n square epsilon naught into h square and absolute square of mu, and then we have the integral from minus infinity to infinity, that is the sum over all possible frequencies emitted within the black body. We have rho nu and delta of nu minus nu naught and d nu. So integrating this one, that is setting nu is equal to nu naught, we obtained the right hand side of this equation, which is 2 pi square over 3 n square epsilon naught h square multiplied by the absolute square of mu, and then this rho which was in the integral now is converted to rho nu naught, because we have solved this integral by setting nu is equal to nu naught. So this is what we have obtained W as shown in equation number 44.9. Now comparing equation 44.7 with 44.9. So we have W from equation number 44.7 and we have also W from equation number 44.9. So if we make the comparison of these two equations, we can get that capital B is equal to 2 pi square over 3 n square epsilon naught into h square, and then this term is multiplied by the absolute square of mu, as shown in equation number 44.10, and using this value we can obtain the value of A. So A is equal to 16 pi cube nu naught to the power 3 multiplied by n multiplied by absolute square of mu divided by 3h epsilon naught into c to the power 3. So as shown in equation number 11. So we have obtained the coefficients B and A. And this is the same as given by quantum electrodynamics approach given in equation number question number 28.7, where capital A was equal to the reciprocal of the spontaneous lifetime, that is A was equal to 1 over tau sp. Sp stands for spontaneous, tau sp stands for the spontaneous lifetime. Note that the transition probability rate is simply called transition probability, and or more simply transition rate, and these terms are what we are using randomly in our approaches. So this is the end of slide number 44.